Sleep, apart from breathing, is the most important thing for human beings. A healthy sleep cycle is made up of several stages with two main states of sleep. The rapid eye movement phase, or REM phase, this is when we're likely to dream, and the non-rapid eye movement phase, or NREM phase, when we experience deep sleep. Both phases are extremely important. To understand how they work, we'll use this graph to track Peter's sleep cycle. From the first moment when Peter begins to fall asleep, he goes through an NREM phase. This is split up into 4 distinct stages as Peter eventually sinks into deep sleep. The next stage sees Peter start to dream in his first REM phase. This is when we're a lot closer to wakefulness and when we're most likely to see someone sleepwalk or talk in their sleep. During an REM phase, a part of the brain called the hippocampus, which is the Greek word for seahorse, processes all the information we've received during the day and feeds it into the smart brain for long-term memory storage. This process is called hippocampal discharge. After an REM phase, the brain waves once again sink back down into deep sleep for a while before moving into another REM or dream phase. It usually takes us around 90 minutes to progress through all 4 stages of NREM sleep and an REM phase. This makes up one cycle of sleep. There are 4 of these cycles in total within a healthy night's sleep. It's then in the final stages of our last REM phase that we wake up. While we're sleeping, a very important process is taking place. During each REM phase, the brain chemical BDNF is produced. BDNF helps the brain to stay plastic or moldable. This means brain neurons can be joined together to form new pathways of communication. BDNF also builds new neurons. If the brain can't produce enough BDNF during REM sleep phases, it will eventually become deficient in this chemical. Without BDNF, new neurons cannot be made, and the existing ones become rigid. The ability to connect to other neurons and form effective communication, particularly between the impulsive brain and smart brain, is compromised. If the brain is unable to create these pathways of communication, the brain will not thrive but merely survive. In addition, the risk of developing neurodegenerative disorders such as Alzheimer's disease and dementia is increased. With such important processes taking place during both the REM and NREM phases of sleep, it's easy to see why a good night's sleep is so vital to supporting the growth of and maintaining a healthy brain. Now one may wonder, how much sleep do we actually need? On average, we need 8 hours. We may not get it all the time, but we should aim for 8 hours of good quality sleep regularly. This will ensure our brains are producing enough BDNF, which will help our brains stay plastic and develop new neurons at a rate that will keep our brains healthy and thriving. And how do we achieve that good quality sleep? Tune in next time where we'll talk about strategies to ensure a sound sleep, called sleep hygiene.